1.3 billion years ago, in a galaxy far, far, far away, two black holes violently collided together. This impact was so great that it caused a ripple in the space-time fabric of the universe. Here on Earth, billions of years later, we were able to detect these waves with lasers. Imagine all of the universe is laid out on a blanket. This is the fabric of space-time. The heavier the object is, the deeper the depression is. Any lighter object nearby will be attracted to the heavier object and move toward the heavier one. Sometimes when two extremely heavy objects, such as two neutron stars or two black holes, are attracted to each other and collide, it creates a ripple in the fabric of our universe. The two black holes were attracted to each other's gravity, so they began circling each other faster and faster until they combined into one larger black hole. This impact was so big that it created ripples, or gravitational waves, throughout the universe. Think of it as throwing a rock in a lake. The water is the universe, and the rock represents the impact of the two black holes, or neutron stars, colliding. Now think of a bobber sitting on the surface. That's a planet. The ripples will move the bobber up and down when they feel this effect, creating waves. The waves are biggest closest to the impact and gradually get smaller the further they go. Gravitational waves are very similar, but to detect them, we use very high-tech lasers. All over the world, there are LIGO sites. LIGO stands for Laser Interferometer Gravitational Wave Observatory, where scientists constantly monitor two lasers, which create beams of 4 kilometers in length and intersect at an angle for proof of gravitational waves. If a gravitational wave were to pass through, it would stretch space in one direction and squeeze space in another direction. Gravitational waves were detected in 2015 when physicists saw the lasers at LIGO microscopically move from each other. They were being pulled and pushed from each other for the first time. Imagine holding two spring-loaded tape measures with two of your friends while you're in a wave pool. As the waves go up and down, you'll become closer and further to your friends, much like the lasers at LIGO did. These waves are incredibly hard to detect because everything that moves creates waves, including sound, walking, cars, water moving, or earthquakes. To make sure they didn't accidentally pick up any other waves that weren't gravitational, LIGO scientists created the smoothest mirrors ever to measure the smallest changes in movement. In fact, 1.3 billion years after the black holes collided, the lasers on Earth only moved 1/10,000th the width of a proton. That may not seem like much, but it's enough evidence of one of the biggest astronomical theories, and hopefully someday this research will give us evidence of the Big Bang.